Hello, this is that 360. Please, if today is your first time of visiting the channel, please subscribe. We have a question here which wants us to find the arc length of a cardioid given by the parametric equation R is equal to 2 plus 2 cos theta. To find the arc length of this equation, the first thing that we need to know is the parametric interval, and as you know, for the full length of the cardioid, it will be given at the interval theta is between 0, so we will say theta is less than or equal to 0, which is also less than or equal to 2 pi. Okay, so once we know the interval, then we can go ahead and say the arc length, which is L, is equal to the integral from the lower limit up to the upper limit. We are using alpha and beta for the lower and upper limit respectively. So the lower limit here will be the 0 and the upper limit will be 2 pi of the square root of r squared plus, then we differentiate r with respect to theta, we square that one also, so plus the r, the theta all squared, or in some books you will see this as equal to the integral from alpha to beta of the square root of f of theta plus f prime of theta all squared. I mean f of theta squared plus f prime of theta all squared is the same thing. So once we know this, we will go ahead and plug in the values for alpha and beta. We know alpha is 0 and beta is 2 pi. We will take the square root of r squared. We know r here to be 2 plus, so we are going to square that. Let me put that in brackets. 2 plus 2 cos theta all squared plus, then we differentiate r with respect to theta. After that we will square it. When we differentiate r, which is equal to 2 plus 2 cos theta, we all know that one is going to be negative 2 sine squared, sine theta all squared, sine theta all squared. And then we are going to integrate the whole of that expression, so we have to add the theta here because of this integral sign on the left side of the equation, or the one that begins the right side of the equation, let me say it that way. So from there we will go ahead and integrate, simplify this square over here. We will say L is equal to still the integral from 0 to 2 pi, the square root of, then we will expand this. If we do that, we will get 4 plus 8, 2 times 2 times 2, that's 2 to the power 8, to the power 3, which is 8 cos theta, and then plus 2 cos theta squared, which will be 4 cos squared theta. And then we will simplify that one also, which will be plus 4 sine squared theta, and then the theta, since we are integrating. So from there, let me see if I can get some more space. Yeah, I can get some. From there, we will go ahead, and you see we have 4 cos squared theta, 4 sine squared theta. We can factorize 4 out. We will have the length to still be equal to the integral from 0 to 2 pi of the square root of 4 plus 8 cos theta, plus, then we factorize 4 out, we get cos squared theta plus sine squared theta d theta. We are still integrating, and as you know, cos squared theta plus sine squared theta is what? Okay, that one is 1. So we will have the length to be equal to the integral from 0 to 2 pi, the square root of 4 plus 8 cos theta plus 4. The whole of that is 1. So 4 times 1. If we are to continue, we will get the length to now be equal to the integral from 0 to 2 pi square root of 4 plus 8 cos 4. Sorry, I forgot to add the theta here, so that's the same thing here. So this is what we get. You can see we can add like terms here. We have 4 plus 4 inside the radical sign. So we will go ahead and say that the length of the arc is now given by the into pi square root of 8, which is 4 plus 4, this 4 here plus that 4, which gives us 8 plus cos theta. Sorry, 8 here. 8 plus 8 cos theta, and then all the theta, like that. We can also do some factorization at this point, so we will do that. We know this will be the integral from 0 to 2 pi of the square root of, we can say 4, 8 here, but we are going to factorize 4 instead of 8. We are going to factorize 4 out, and that will give us 2 plus 2 cos theta. We did factorize 4 because 4 is a perfect square. D theta. So if we are to continue, we will get L, which is equal to, let me get some space, which is equal to, then we can bring root 4 out, which will be something like this: the integral from 0 to 2 pi of root 4 multiplying root 2 plus 2 cos all of this d theta. And now this root 4 can be written as 2. We will have L as equal to, now we can bring the 2 first before the integral sign, from 0 to 2 pi of the square root of 2 plus 2 cos theta, all of this d theta. I believe everything is cool. We are going ahead. Next thing that we are going to do is we have this trig identity, which goes like cos 2 alpha which is equal to what? 2 cos squared alpha minus 1. This is a trig identity. I did not make this up. Let's add 1 to both sides. We'll get 1 plus cos 2 alpha to be equal to 2 cos squared alpha minus 1 plus 1. Don't forget we are adding 1 to both sides. That will give us 1 plus cos 2 alpha to be equal to 2 cos squared alpha. Now let us multiply through by 2. So multiplying by 2 will give us here times 2 and here times 2. So we will get 2 plus cos 2 cos 2 alpha to be equal to 4 cos squared alpha. I believe that's right. Okay, so now let's substitute alpha is equal to theta divided by 2. Alpha is equal to theta divided by 2. That also gives us, let me move this up a bit. Sorry. So we are now saying alpha is equal to 2 theta divided by 2. Sorry, theta divided by 2, or 2 alpha is equal to theta. So when we do that, we are going to get 2 plus 2 cos 2 alpha, and we know alpha to be theta out of 2, and now it's equal to 4 cos squared alpha, which is theta divided by 2. Everything okay? All right, so if we go back to the formula for finding the length here, let me go up a bit. This one here, we saw this whole thing here was the trig identity thing. This one here was for the trig identity that we used. We are going in here to substitute that whole thing that we got, and we had this one here, the one up here. We are going to do that substitution. Let's go down a bit. I'm going to copy it first before we do the substitution. We had L is equal to 2 the integral of 2 plus 2 cos theta. So I will write that down here, and then we do the substitutions that we wanted to do. We have L is equal to 2, and then the integral of from 0 to 2 pi as the limit, the square root of 2 plus 2 cos theta d theta. I think that's what we had. Okay, and now we are saying we have this expression. Head and substitute that. Let me go up a bit. we will have L, which is the length, to be equal to 2 times the integral from 0 to 2 pi. And then here we are going to get, let me go up a bit so that you can follow as we do it. Come on. We are going to get 4. Don't forget this, and that is going to cross. And this is 2 plus 2 cos theta. You see it here. And we are now saying the whole of that is equal to 4 cos squared of theta divided by 2. Is everything okay? Okay. D theta. At this point, we also have, as you can see here, we have 4 in the radical sign, and we know the square root of 4 is 2. We can also factorize that one out. I'm going to shorten it, like skip some steps. It's going to be 4, which will be that this root 4 here is 2. Multiplying this 2 will give us 4 times the integral from 0 to 2 pi, the square root of cos squared theta divided by 2 d theta at this point we also have cos squared being squared, and we have to take the square root of that, and you know the square and the square root can leaves us with the length being equal to 4 times the integral from 0 to 2 pi of the absolute value of cos theta divided by 2 d theta. It is necessary to take the absolute value of cos theta because we know cosine is negative for some values in this domain that we are working with. Another way of doing this is if you don't want to do the absolute value, you can take the limits from 0 to 2 pi to 0 to pi, which would be like half of whatever we are doing, and then after that you double the result that you will get. Let me do that here. So if we had to go by that, we will say the length will be 2. That's a double thing. Yeah, double theta divided by 2 d theta. That's if you do not want to do the absolute value thing. This will leave us with 8. 8 being equal to, come on, the length 8 times the integral from 0 to pi of cos theta divided by 2 d theta. Continuing, we will say the length will be equal to, then we will take the integral again with 8 over here. Now we are going to integrate cos theta divided by 2, and that will give us, if we are integrating, then we don't need the integral sign. Let me do away with the integral sign. So we will have the length to be equal to 8 times, if we integrate cos theta divided by 2, we will get 2 sine theta over 2, and we are going over this interval from 0 to pi. So the first thing that we will do is we will evaluate this when pi is 0, and then after that we will do it when pi is equal to theta, or theta is equal to pi, and that will leave us to get L. So if we are to go step by step, we will do 8 times 2 sine pi over 2 minus 8 sine 0 over 2, that in bracket 8 times that, and this leaves us with a length, with a length of equal to 16 units. 16 units. So that will be the end of the question. I believe everything went on well. You understood everything. So we can conclude by of the cardioid. R is equal to 2 plus 2 cos theta equal to, let me use green, is equal to 16 units. I think that's what we got. 16 units. Yeah. That'll be 16 units. Thank you very much for watching. I will see you next time in another video. Thank you very much. Bye bye.